In this example, we're going to calculate the net torque acting on a system of two objects. Let's suppose that two discs are placed on top of one another and attached at the center by a hinge that acts as the axis of rotation. So the smaller disc has a radius of 40 centimeters and it's placed on top of a larger disc that has a radius of 70 centimeters. So they rotate about the axis of rotation found at the center. Now, let's suppose that three forces are acting on our system of two discs. Force number one is acting on the larger disc that has a magnitude of 100 newtons. Force number two has a magnitude of 50 newtons and it also acts on the larger disc. And force number three acts on the smaller disc. It has a magnitude of 30 newtons and it acts at an angle 30 degrees with respect to our y-axis. Now, using this information, we'd like to calculate the net torque acting on our system of two discs. So we begin by choosing the counterclockwise direction to be positive and the clockwise direction to be negative. So that means the only force that creates a torque that points in the positive counterclockwise direction is force number one. Force number two and force number three point in the clockwise direction. They create a torque in the clockwise direction, and that means they are both negative. They create negative torque. So, let's begin with the following equation. The sum of the torque is equal to, well, torque 1 minus torque 2 minus torque 3. So what exactly is torque 1? Remember, torque is simply, we take the force that acts at a perpendicular angle and multiply by the lever arm. So we have force 1 perpendicular to lever arm 1 minus force 2 perpendicular times lever arm 2 and minus force 3 that is perpendicular to lever arm 3. Notice R1 and R2 are exactly the same. It's 70 centimeters or 0.7 meters. And R3 is simply the radius of the smaller circle. It's 40 centimeters or 0.4 meters. Now, notice the force 1 is perpendicular to the radius of the larger circle. So that means that F1 perpendicular R1 is simply 100 newtons times 0.7 meters. Now, the same exact thing is true for force number 2, but it acts in the opposite direction. So we subtract minus 50 newtons times 0.7 meters. Now, the only tricky part is force number 3. Force number 3 acts at a 30-degree angle with respect to the y-axis and a 60-degree angle with respect to our x-axis. So that means in order to calculate the force that acts perpendicular to the smaller disc, we have to take the force, the magnitude of force 30 newtons, and multiply by sine of the angle 60, because we're looking for this force that points along the y-axis. So we have 30 times sine 60 times our 0.4 meters, the radius of the small circle. So we get 70 minus 35 minus approximately 10, and we get approximately positive 25 newtons times meter. So that means our value of the torque is positive, so the object will rotate in a counterclockwise positive direction with a value with the torque, net torque of 25 newtons times meters.